Hello. So in this video, we're doing section 8.1, what is a function? And this is the most basic thing in the course, are functions. So the very first line says blank in Math 1200 is about understanding functions. It starts with an E, and the answer is everything. Everything in Math 1200 is about understanding functions. Calculus is short for calculus of functions, which means how to calculate with functions. So this whole course is basically some really good tools for understanding functions, because functions are sort of everything in this branch of math. So everything in real life that can be handled with this kind of math, you turn it into a function, then you hack at it with the tools you have for dealing with functions. That's what we're doing in the course. So we better start with really knowing what a function is. So let's see, there's this big box here with what is a function. A function is a machine that has inputs and outputs. And here's a notation maybe you haven't seen before. F, A, arrow B, that's the notation. That means that F is a function that inputs things in A and outputs things in B. So sometimes people draw a little box like this, and they think of F as a machine, and the machine has two sides. It has one side where it's inputting things, and here you feed in things from A. So you take something from A, you feed it in, and you get something out, and that something will be in B. So that's what this notation, F, A to B, that's what that means. So A is some kind of set of possible inputs, B is some kind of set of possible outputs. So these two things have a name. The possible inputs are called the domain of the function, and the possible outputs are called the range. So domain and range, you probably have heard of these before. So that's what a function F means. We're talking about some function F. We use F for function because we're lazy, and also F is pretty quick to write. What does the notation f of x mean? And so you surely have seen this before. F of x is the output of f when the input is x. So as a picture, if you take some element x, which is in the domain, you feed it into f, it goes through the machine, and out on the other side comes f of x. So f of x is the output when x was the input. So that's what a function is, domain and range, this funny notation f, a to b, and f of x. Okay, here are a couple little minor points. So one thing, in general, functions can input and output anything. So you could have a function where the input is time. You could have a function where the input is the height and weight of people, and the output is how likely they are to have cancer or something. You could have all sorts of crazy functions. Many of them are useful in real life. In this course, though, we're going to have something that is nice. It's going to be a little simpler. So in Math 1200, all of our functions have a domain and range, which are always numbers. Symbolically, all the functions in Math 1200, they're f blank to blank, and the blank is this symbol r. R represents all real numbers. So the inputs in Math 1200, they always input some real number, and they output some other real number. And that means that the domain and range are a little bit simpler. They're which possible numbers could be the input, that's the domain, and the range is which possible numbers could be output. That's the range. So you don't have to worry about complicated things in Math 1200. You only have to get really good at functions that input and output exactly one number. Here's one other point of confusion. So far we've talked about a function f, and f of x is the output. So f of x is some number. But oftentimes people mix these up. So even though a function is its own thing, so we call it f for function, and strictly speaking, f of x is a number, right? F of x is the number you get when you input x. The value of the output when x is the input, it's very common to write f of x sort of to generically refer to the function. So for example, someone might write f of x is a nice function. Saying f of x is a nice function, like, this is slightly confusing because f of x is actually a number. It's not a function, right? F of x is the number you get when you feed x into the function f. So f of x is a nice function technically doesn't make any sense. Something's gone wrong. But people often write this down, and it means exactly the same thing as saying f is a nice function. So people often interchange f with f of x, right? So f is the actual function. F of x is technically the function at some point x, but people mix these up all the time. So just be on the lookout for that. That will happen all the time. Okay, so that's what a function is. How do we represent functions? Well, in this course, the most common thing is the formula, what I call the formula representation. So in the formula representation, we just give you a formula. We say the formula for f of x is do the following operations to x. So a formula for what to do with x. So everyone's favorite example is the squared function, f of x equals x squared. This is the function. You input x, and the output is x squared. So the output is the square of the input. And of course, there are many, many types of functions. The next section, section 8.2, is on bread and butter functions. Those are the simplest functions that we're going to use all throughout the course. So there'll be lots of examples of these functions coming up soon. So that's the formula representation. Another point to notice here that people get sometimes tripped up on is when you're giving the formula for a function, the variable that you use, so the x that we used, that is just some kind of generic placeholder variable, and it doesn't matter what you use. So for example, the function f of x equals x squared and g of a equals a squared, those represent the same exact thing. So they both take something in as input, they square it, and that's the output. Therefore, these two things are the same. So you can use any variable you want. F of x equals x squared is exactly the same thing as f of spades equals spades squared. So whatever you input, you output the thing squared. Don't get too attached to the variable x, right? It could be anything. That's what's going on in this bullet point. Here is another important rule. When someone gives you a formula, the domain, unless they say otherwise, the domain is always what numbers does the formula make sense for. So when you're given a formula, sometimes the formulas won't be defined at all points, and the rule is the domain of the function is exactly where the formula is defined. So here's an example one, or two sort of simple functions. F of x is a 1 over x minus 2 is part A, and we're told to find the domain of this guy. So what is the domain of this guy? It's wherever it makes sense. So when is it okay to divide by x minus 2? Well, you can't divide by 0. That could be the only possible problem. If x minus 2 is anything other than 0, it's no problem. You just divide by x minus 2. But when x minus 2 equals 0, it's not defined. So not defined at, let's make a little note here. Not defined at x minus 2 equals 0, because then you're dividing by 0. So therefore, x minus 2 equals 0 is the same as x equals 2. So it's not defined at that point. So the domain is all numbers except for 2. So that's the domain of that function. And later on in the course, we're going to have maybe more fancy notation for writing sets of numbers. But for now, as long as you understand all numbers except for x equals 2, that's great. Okay, here's another maybe more complicated one. The function square root of 25 minus x squared. And just like before, where it's fine for a lot of numbers, but there's a key technical thing that happens, you can't take the square root of a negative number. Okay, so strictly speaking, you can do complex numbers, but in this course, everything is about real numbers. So you can't, in Math 1200, you can't take the square root of a negative number. And because you can't take the square root of a negative number, this function is not defined when 25 minus x squared is negative when it's less than 0. And 25 minus x squared being negative is the same as x being bigger than 5, or x is less than minus 5. See math. So it's not defined if x is bigger than 5, or if x is less than minus 5. Part of the course is later on in the course, we're going to learn how to do this more formally, how to go from here to here. But for now, it's okay. You can just think about it however you want, or you can just take my word for it. For now, we're going to do it in more detail later. So 25 minus x squared being less than 0 is the same as x being bigger than 5, or x is less than minus 5. And that's when the function is not defined because you can't take the square root of a negative number. So what is the domain of the function? It's domain is all numbers between negative 5 and 5. So I'm going to write it like this. X is between minus 5 and 5. It's bigger than minus 5 and less than 5. And I think actually equals is okay. Then you just get 0. That's fine. So negative 5 between, x is between negative 5 and 5. Okay, here's another bullet point. A lot of people say, okay, but what about the range? Finding the range turns out is not as important. So don't get too hung up on finding the range. Finding the domain is very, very important because you need to know what you can plug in. Usually you don't need to find the range, and we'll maybe do a couple examples later in the course where we do, but not a ton. Okay, that's the domain of a formula. Another way you can see functions is as a table. So as a table of values, you just list out a bunch of values. And the problem with tables is that they get very long. So you can't include all possible values in your table, especially when there's infinitely many values. So for example, in the last examples we did, x could be any number between -5 and 5. There's infinitely many numbers like that. So you couldn't possibly contain all these on a table. In real life, of course, you get a lot of tables. So it's good to have tables in the back of your head. So here's an example. Suppose f is a function whose domain is all numbers. So it's some function from R to R whose domain is all numbers. Domain. So the domain is everything is R. Here are some of the values of f. Can you think of a formula that could be the formula for f? And it's a nice pattern here. So the x values go 0, 1, 2, 3, 4. And the f values, they go 0, 1, 3, 6, 10. So these are called triangle numbers. So they go up by 1, then it goes up by 2, then it goes up by 3, and then it goes up by 4. So you have to figure out, can we figure out a formula for the function f based on this table? And of course, the could is important here. There are many possible formulas because we've only told you the value of f at 5 points. And so there are sort of infinitely many ways to fill in the gaps in between those 5 points. But one possible simple formula, and this is the formula for the sum of the first few numbers, is this, f of x. I should say, you should maybe pause the video and think about it for yourself for a second. But one possible formula is this, x times x plus 1 divided by 2. So that will work, and it will go through these points. So that's a possible way of going from a table to a formula is doing this. In real life, you get tables, and then there's a whole field of statistics and things about how to convert that to formulas that are reasonable. We're not going to be doing a ton of tables in this course, but it's good to know about. Okay, the last way to represent a function is as a graph. So the way a graph works is you take all the possible x values in the domain and you draw a dot at the point x, f of x. So I'm sure you've seen lots of graphs before. Here's an example. Draw the graph of the function square root of 25 minus x squared. That was the function we did before. We know its domain is between -5 and 5. So the function is definitely going to live on this thing. And the question even says use a computer if you need to. So if you've never seen this function, you can draw it on a computer. If you have seen the function, you might know what it looks like. So take a guess on what you think it looks like. I'm gonna cheat here and use a Desmos. Okay, I guess it's not cheating because it said I could. Let me hit the graphing calculator button on Desmos. And let's put in square root 25 minus x squared. So what does this look like? So this is a semicircle. It's the top half of a circle. So let's go back here. We can draw it in. So it's a circle. The height is, let's see, what could the height be? If I wanted to figure out the height of the circle, well, the height is this point up here, and that's when x equals 0. So to figure out the height, I could plug in x equals 0 into f. So the height here, the height is f of 0, and f of 0 is the square root of 25 minus 0 squared, which is the square root of 25, which is 5. So remember, the square root function always outputs the positive part. So there's two numbers whose square is 25. Square root of 25 is just 5. Okay, so the height here is also 5. And we know it's a semicircle from graphing it. So it looks something like this. Oh boy. Oh boy, this is not a great graph. Okay, so there you go. Semicircle for the function f here. Label the points on the graph where the x value is 3 and -4. So if we plug in x equals 3, so the height here will be f of 3. We're plugging in x equals 3. And f of 3 is the square root of 25 minus 3 squared. That's 25 minus 9, which is the square root of 16. It's a nice value. That is 4. So this point here is the point 3, 4. So that's how this point was the point 0, 5. That's how graphs work, right? You take the x values, you take the f of x value as the height, and you put them together. So sometimes people say this is the y coordinate equals f of x is really what we're drawing. So that's another way to think about this. The last thing we got to do is at x equals -4. So at x equals -4, at x equals -4, the height is going to be f of -4. Let's say y equals f of -4. So the square root of 25 minus -4 squared. That's 25 minus 16, which is 9. So get the square root of 9, and that's 3. So this point is -4 over and 3 up. So there we go. We have f with 3 points labeled 3, 4, -4, 3, and 0, 5. That's graphing functions. Again, probably you're very good at graphing functions, and this is going way too slow for you, which is why these are online instead of being done in class. Okay, last point to make. Not every curve is the graph of a function. The graph of a function only intersects each vertical line at most once. So in this picture, we had half a circle. And as an example, if you had a full circle, so for example, x squared plus y squared equals 25, that would not be the graph of a function. So if we go back to Desmos, Desmos is really smart. So if I turn off, let me turn off this graph in Desmos, and let me make a new graph, which is x squared plus y squared equals 25. So now it's giving me a full circle, and this is not the graph of any function. So a function is something with inputs and outputs, right? You give me x, I have to tell you what the value is, and that means in each vertical line, that's for one x value, you can only have one possible output. When you type in x squared plus y squared equals 25 in Desmos, you're not defining a function. What you're telling Desmos is, please find all the possible x and y pairs that have x squared plus y squared equals 25. And it turns out that that is not the graph of a function because it intersects these vertical lines twice. So for every x value, there's 2 y values, and that means it can't possibly be a function. So of course, you know, these things are related, right? Like x squared plus y squared equals 25 is related to the function that we had before, square root of 25 minus x squared. That's the top half of the circle. So if you wanted to make this blue thing, x squared plus y squared equals 25, into functions, you would have to use at least 2, maybe one for the top half, one for the bottom half. And we'll talk a little bit about that later in the course when we do implicit functions. But for now, just be aware, any random squiggle may or may not be a graph. It needs to intersect each vertical line once. Okay, and that's it for what is a function. Let me see, was there anything else? I think that was it. That's it for what is a function. In the next video, I'm going to do the bread and butter functions, which are the sort of simplest possible functions that you need to be very familiar with.